In the world of machine learning, there are several important metrics that help us evaluate the performance of our models. Today, we will dive into the differences between precision, accuracy, recall, and F1 score. Let's meet our character, Machsrtyk, who will guide us through this journey. Imagine a scenario where Machsrtyk is a detective trying to solve a crime. He has a list of suspects and wants to identify the guilty one. In this story, Machsrtyk symbolizes our machine learning model. To comprehend this better, let's dive into the concept of precision. Precision measures how many of the identified suspects are actually guilty. In essence, it communicates how accurate our model is in pinpointing the true positives. If Machsrtyk accurately identifies 8 out of 10 guilty suspects, his precision would be 80%. To illustrate this concept further, let's consider the real-world application of machine learning in email spam detection. In this case, precision would be the measure of how many emails flagged as spam were, in fact, spam. If out of 100 emails marked as spam, 90 were actual spam, the precision of our model in this project would be 90%. Furthermore, in a health diagnosis system, precision plays a significant role. Suppose the system identifies 200 patients as positive for a certain disease, out of which only 150 are true positives. In this scenario, the precision of our system would be 75%. So, precision is calculated as the number of true positives divided by the total number of items labeled as positive, either correctly or incorrectly. This value is then multiplied by 100 to get the percentage. It is an integral part of evaluating the performance of machine learning models, giving us a clear understanding of how well our model is identifying the correct class. Moving on, we delve into accuracy. This is a crucial metric in machine learning, reflecting the overall performance of our model. It provides us with the percentage of correctly identified data points, be it in identifying suspects, predicting whether, or even classifying emails as spam or not. Consider a scenario where our model, Machsrtyk, accurately identifies 18 out of 20 suspects. Here, the accuracy is 90%. Look at another example. An email filtering algorithm classifies 950 out of 1,000 emails correctly, resulting in an accuracy rate of 95%. Or a weather forecasting model, predicting tomorrow's weather with an accuracy of 80%. You see, gauging accuracy forms a critical part of these machine learning projects, being a telling sign of how well our model performs in a variety of applications. Let's delve deeper into recall. Recall is a critical metric in machine learning projects. It is used to measure the model's ability to correctly identify true positives. Simply put, it's the percentage of actual positive cases that the model has accurately classified. Let's take an example. If our model is tasked with detecting fraudulent transactions among a pool of credit card transactions, and it correctly 500 out of 600 fraudulent transactions, then its recall would be approximately 83%. Another instance could be a model designed to flag spam emails. If there are 200 spam emails and the model correctly flags 180, the recall would be 90%. In medical diagnostics, if a model is built to identify patients with a certain disease, and it correctly identifies 40 out of 50 patients, the recall would be 80%. Using recall, we can ascertain performance across a diverse range of machine learning projects. From identifying fraudulent transactions, flagging spam emails, to medical diagnostics, the metric offers robust performance evaluation across the board. In conclusion, we explore the F1 score. The F1 score, often employed in machine learning projects, is a harmonious blend, precision and recall. It offers a balanced analysis of model performance, accounting for both false positives and false negatives. For instance, if Machsrtyk's precision is 80% and his recall is also 80%, his F1 score would be 80%. Let's consider some additional examples in machine learning applications. Suppose in a spam detection project, if the precision is 90%, indicating that 90% of the emails labeled as spam are indeed spam, and the recall is 75%, showing that 75% of the actual spam emails were correctly identified, then the F1 score would be 81.8%. In another scenario, imagine a medical diagnosis model. If the model has a precision of 95%, suggesting that 95% of the patients labelled as sick, truly ill, and a recall of 70%, meaning that it correctly identified 70% of the actual sick patients. The F1 score here would be 80.6%. Essentially, the F1 score harmonizes precision and recall, which can often be at odds, resulting in a more balanced model performance evaluation. It helps in situations where both false positives and false negatives are crucial to consider. In conclusion, each of these metrics, precision, accuracy, recall, and the F1 score, plays a crucial role in the realm of machine learning. For instance, consider precision. It primarily concentrates on ensuring the veracity of positive predictions. This is similar to a detective who is so precise that they only apprehend the real culprit, while leaving all the innocent individuals untouched. Then we have, which is like a school exam's overall score. It essentially evaluates the performance on a broader scale, indicating how well the model is doing overall, just like your total score reflects your knowledge subjects. Recall, on the other hand, is all about the model's capacity to pinpoint positive instances. Imagine a searchlight that can illuminate all the hidden treasures in a dark room. That's your recall metric. And finally, the F1 score. It is akin to a balanced diet, providing an equal proportion of precision and recall. It's as important as getting the right balance of carbohydrates, proteins, and fats in your meals. So when you're tackling a machine learning project, these are the metrics you should be eyeing. To focus on precision to avoid false positives, strive for high accuracy for overall performance, aim for good recall to catch as many true positives as possible, and seek a high F1 score for the best balance between precision and recall. Next time you come across these terms in machine learning, remember this analogy and the value they bring in assessing your model's performance.